Alright, so here we've been given this identity here. We have been given this identity here, and our task is to verify it. Okay, so we're going to take the most complicated side, which is the left hand side, and we see that it has two identities. We have cos x plus y and cos x minus y. Alright, so expanding the first one, which is cos x plus y, we are going to see that we're going to have that first identity there from the sum and difference identities. Expanding the second one, we must have something like that. Okay, now reaching at this point, we need to open the brackets, we need to multiply this expression times this expression. So to make your work less difficult and less confusing, let us pretend this expression here, cos x cos y, being represented by a simple letter, let's say a, and then sin x sin y, sin x sin y, sin x sin y being represented by a simple letter, let's say b. Therefore, in the first bracket we'll have something like this, second bracket we'll have something like this, and then if we multiply them, it's going to be a squared plus ab minus b squared, right? And then we see that these things, they'll cancel out. We're going to remain with a squared minus b squared. But what is our a and what is our b? We saw that our a was the cos x cos y, and then our b is sin x sin y. So that is why you see this statement here that says difference of two squares. Okay, so that is just a way of verifying that this was actually a difference of two squares. But if you know your difference of two squares very well, you don't have to show the process, you just have to get the a, square it, get the b, square it, and put a minus sign there. So that is how we came up with this expression here. Now once we reached here, to move further downward, we need to find an identity such that our answer will give us that there. So we're going to replace cos squared y with its identity, with its Pythagorean identity, from the one that goes like cos squared x plus sin squared x will give you 1. Therefore, the identity of one trig ratio is 1 minus the identity of the other trig ratio. So here we have cos squared y, meaning its identity will be 1 minus sine. Alright, so we have cos there, you're going to have sine. So that's how we came up with that. And then here the second part is that we're going to keep the sine squared y, which is here, and then we're going to find the identity for sine squared x there. Okay, so I kind of like switch them there. So sine squared x will give us 1 minus cos squared x there. Alright, and then from there now all we have to do is multiply what's outside with what's inside. So that multiplied by that, that's that multiplied by that is that there, that, negative, negative, giving you a positive. Be careful with that. And then we see that here it's negative, here it's positive, so this will sort of like cancel out, and then you remain with your cos x minus sine y squared. Yeah, and that is how you do that identity, and you can proudly say, hence proven. Okay, that's a horrible handwriting.